Okay, for question 5, we're going to be using quotient rule. Now remember, quotient rule is when you're taking the derivative of something being divided by something else. So the formula is derivative of the top times the original bottom, subtraction original top times the derivative of the bottom, all over the original bottom squared. Okay, so for all these, we're going to follow that format. So, first example, we have 3x plus 2 divided by x squared plus 1. So if we go ahead and follow that format, we have the derivative of the top. The derivative of 3x is 3. The derivative of 2 is 0 times the original bottom. Subtraction times the original top, 3x plus 2, times the derivative of the bottom. The derivative of x squared is 2x, and the derivative of negative 1 is 0. All of that over the original bottom squared. Okay, so right there, that would be the derivative. The next step would be to simplify. Now, generally, we're going to simplify the numerator. So here, to simplify the numerator, we're going to distribute the 3. So in the numerator, we're going to have 3x squared minus 3. Now be careful, we have to distribute the minus and the 2x. So I'm going to suggest distributing the negative 2x, so we can just do it all in one step. So that would be negative 3x squared minus 4x all over x squared minus 1 squared. Then we can continue cleaning up the numerator, simplifying, combine like terms. 3x squared minus 2x squared is negative 3x squared. Then we have minus 4x. Then we have minus 3 over x squared minus 1 squared. That would be the final simplified answer. Final simplified answer. Okay. Next, the other one. Same thing. All of these are going to be quotient rule. All these are going to be quotient rule. Just going to be careful. Be careful taking the derivatives. So, quotient rule, derivative of the numerator. Derivative of 5x to the 1/3. 1/3 times 5 is going to be 5/3 x. 1/3 minus 1, you can use your calculator if needed. That would be negative 2/3 times the derivative of negative 4, which is 0, times the original bottom, the original denominator, minus the original top, 5x to the 1/3 minus 4, times the derivative of the denominator. So the derivative of 7x squared is 14x, the derivative of 2x is 2, and the derivative of negative 1 is 0, all over the original denominator, the original bottom squared. Okay? Again, that's the derivative. We did the derivative correctly. Be careful, be careful, be careful. Now, the next step is we're going to simplify the numerator. And when we simplify the numerator, we're going to go nice and slowly, nice and slowly. So we're going to distribute the 5/3 x to the negative 2/3. So 5/3 times 7, again, you can use your calculator if needed. That would be 35 over 3 x. Then with the exponents, x to the negative 2/3 and x squared, we add them. So if you need your calculator, you can use that. Again, use parentheses. So for example, parentheses negative 2 divided by 3, close parenthesis. And you're multiplying that, so you're going to add it to the 2, because when you multiply, you add the exponents. So we add 2. That gives us 1.33333. If we hit math, number 1 for fraction, that changes it to 4/3. So again, if we're a little confused, we can always use the calculator. Always use the calculator to help. 4/3. Then we have 5 over 3 times 2. Again, you can use the calculator for that if needed. That will end up being 10 over 3. X, this is negative 2/3. This is 1. When you add that, you get 1/3. If needed, use the calculator. Then we're going to have 5/3 x to the negative 2/3 times negative 1, which will give us negative 5/3 x to the negative 2/3. Okay, that's the first one. Now, for the next one, we want to be very careful because we have this minus, the subtraction. We're going to leave it there. Then I'm going to put parentheses. Then we'll do the distribution, distributive property, and then we'll distribute that minus. So be very careful with this. So we have 5 times 14. Again, if you need to use your calculator, take out your calculator. 5 times 14, and you get 70. And then remember, with the exponents, you add the exponents. So x to the 1/3 times x to the 1, you add, that would be 1 1/3 or 4/3. Then we have 5x to the 1/3 times plus 2, which would be plus 10x to the 1/3. Then we have negative 4 times 14. Again, if you need to use your calculator, no problem. 4 times 14, that gives you 56. That would be a minus 56x. And then negative 4 times 2 would be minus 8. All over 7x squared plus 2x minus 1 squared. Okay, but remember, we still need to distribute that minus. So the next step would be to continue cleaning up. So we have 35 over 3, x to the 4/3, plus 10 over 3, x to the 1/3, minus 5/3, x to the negative 2/3, minus 70x to the 4/3, minus 10x to the 1/3, plus 56x, plus 8, all over 7x squared plus 2x minus 1 squared. Then we're going to combine like terms. We're going to combine like terms for our final answer. We generally have the highest exponent and work our way down. So if we take 35 over 3 x to the 4/3 minus 70 x to the 4/3. So if we do 35 over 3 minus 70, so parenthesis 35 over 3 minus 70, enter math fraction number 1, and that gives us negative 175 over 3. So that's negative 175 over 3 x to the 4/3. Then continuing with the highest exponent down would be the 1/3. So we have 10 over 3 x to the 1/3 minus 10 x to the 1/3. So we can go to the calculator, parenthesis 10 over 3 minus 10, enter math fraction. You get negative 20 over 3. So you have negative 20 over 3 x to the 1/3. Then we can put the plus 56x, plus 56x. Then we could put the minus 5/3 x to the negative 2/3. We can also bring that to the denominator if we wanted. Plus 8 all over 7x squared plus 2x minus 1 squared. Again, please separate. Are we comfortable with the quotient rule? Then, are we comfortable with the algebra? And is it the fractions? Is it the decimals? Is that what's throwing it off? Is it the algebra? Is it the derivative? Be very, very careful trying to figure out what is the issue. What is the issue there? Okay? Then, notice we can also do that with special cases. So we have two things being divided, so we're going to follow quotient rule. So, derivative of the top, the derivative of 3x squared is 6x. Derivative of minus 4 is 0 times the original bottom minus the original top times the derivative of the bottom. The derivative of ln of x is 1 over x. All over the original bottom squared. Okay, so make sure we did the quotient rule correct. Then to clean this up, not too much we're going to do here, but this would be 6x ln of x minus, maybe we put the 3x squared minus 4 over x all over the ln of x squared. And that would be your final simplified answer. And for the last one, we have 3 raised to the x divided by e raised to the x. So again, nice and slowly, follow quotient rule. Derivative of the top. Well, the derivative of 3 raised to the x is 3 raised to the x times ln of 3. The last step would be the derivative of 1x is 1, but that won't change anything, times the original bottom, minus the original top, times the derivative of bottom, derivative of e to the x is e to the x, all over the original bottom squared. So basically, just to kind of clean it up a little bit, not really a particular order, but I would maybe do 3 raised to the x times ln of 3 times e to the x minus 3 raised to the x e to the x all over e to the x squared. Then you can leave it like that. That is a completely fine, totally simplified answer. But some of you may be saying, well, couldn't you pull out or factor something? Yeah, you could pull out the 3x e to the x, and then you'd be left with ln of 3 minus 1 over e to the x squared. Then yes, if you want to keep simplifying a little bit further, the e to the x over the e to the x, you would have 3 to the x ln of 3 minus 1 in parentheses. But again, either one, the bottom would be the most simplified. But that's